All right, we'll resume. Next up, we have Robert Collins talking about reliable testing with pip. He works for HP and he's also helped organise this mini-conf, so please make him feel even more welcome.
And today I learned how to turn the microphone on. So, mouse on the right window. Right, so, got a problem. And that's interesting. All right, okay, good. All right. So, you want to do some testing of your code. You probably want to put it in CI. You want to be able to have it be run by a robot that will do it right and accurately and make it work every single time. But as soon as you've done that, you're going to want to deploy it somewhere. So although this title of this talk is about reliable testing, really it's talking about reliable deployments, because you want to know that that's going to work. And, well, the story is frankly horrible. This isn't a talk about Docker, by the way, just to be clear. We're not going to go down that path. I love Docker, but this is not that talk. If your packages are coming out of Linux, any Linux, they're ancient. Python-specific packages. It's a Python conference. We're talking about Python code. And when I say ancient, they might be last month or they might be last decade, but either way, they're not going to be the versions that the maintainers have put up on PyPy and have published for you to use. They don't have the latest security fixes until someone says, actually, that package is used by more than 3 people in Upper Canada and really does need a CVE number allocated and pushed out into the distros, and then, yes, it is big enough to put into RHEL, and it's just a nightmare. So let's not talk about Linux. Docker, great, but you're going to either be talking about all the other stuff I'm talking about, or you're going to be using distro packages within Docker, and it's going to have exactly the same narrative. You do an update before you build your image, you've got some deployment stuff, it doesn't help. So pip gets you the latest code. It's got all of the security fixes. There's one big caveat there. It's the latest code, and updates break the world. The more dependencies you've got, the worse this gets. So your problem really isn't about testing your code or deploying it. The problem is other projects. We don't want them. We don't want loose coupling, but actually we do. It's a valuable thing. So we need to acknowledge that people will make mistakes, other projects will make mistakes, we'll make mistakes in the way we use other people's code, and major version boundaries kind of get interesting because that's when they signal that they have deliberately broken something, and you've got to choose between having the latest, most secure, and fastest code or being broken. So there are a bunch of existing solutions in this space, and some of them are pretty good. I like this one. Don't use any other code at all. If it's all in your tree, you can't be broken by anyone else. It's fantastic. Some people might say that this is kind of bad on collaboration and on, repeating yourself in the ecosystem, but, what do they know? Another option people take is they say, we'll build everything into distro packages, because distro packages can express extremely complex dependencies, and they can say what they will break and what they won't break, and we get completely consistent deploys, and it's a huge amount of work, and you don't gain a lot. You gain a little bit, but you don't gain a lot. But you end up running an entirely parallel tool chain, and you can't use any of the tooling that's been built up in the Python ecosystem, for example, Tox and DevPy and things like that. And you also get into conflicts with your distro vendor. You have to fork their packages, however they've been packaged, to do an update to something that is in the distro. I don't recommend it as a path. I've seen lots of people go down it and build very sophisticated things that work, but it's a lot more effort than just being kind of low-key. You can run a manual PyPy mirror. I know an organization, OpenStack Infra, that did that for a while. It's, no, it wasn't.
Sorry, I got it wrong.
Yeah, Monty said he thought it was fun. What he meant was he spent a lot of time drinking.
That was fun.
So what happens is that when the mirror gets an update from PyPy, it gets it in a fairly non-deterministic fashion. If you're running Bandersnatch, it is quite deterministic, but when something goes wrong, you might skip a particular package because a mirror's down for a second or something, and then you get an error and your mirror is in an inconsistent state. There's no way to guarantee that what you let in through that mirror push is actually compatible. So you have to run two mirrors, and then you have to pivot between them to say, is this one still working, or did it break something and I can't turn it on? And then when the package you really care about has an update, but that came in right after a package that you didn't care about that broke something, you haven't actually gained anything versus figuring out some other way of solving it. Because you still are in the position where you've got a fire drill. To get that update you need, you have to solve your problem with the package you didn't really care about. And another route is to put really tight bounds in your setup.py dependencies to say, hey, I'm going to work on any of the Python, what have I got as an example there? LXML 3.4 releases. Really, really tight bounds. Now, this kind of works as long as no one accidentally breaks something in a point release or a patch release, which does happen. And it's got a really bad side effect. When you cut a release from your project like this, you really bind the dependency resolver in pip, which is somewhat crude today, to just that version of LXML. Now, if you've got another project that comes along that you're interacting with that says they don't work with that version of LXML anymore and they need a newer version, one of two things will happen. You'll either have your boundaries ignored, which means they weren't really offering you anything in the first place, or you won't install the version of LXML that that other thing you depend on needs, and everything's going to go up in flames. You can vendor everything. You can take a copy of all your dependencies, put them in your code base, and then when you want to update them, you take a copy of the updated thing, you put it in your code base, and you commit it. Now, this is actually really, really good for some special cases. But it breaks when you've got multiple projects. So if I've got two code trees, say I'm in the microservices architecture and I've got one service that knows how to talk about users and another service that talks about projects or something, they won't necessarily agree on the code in those trees. Now, microservices are actually relatively fine. We're talking over the web between them, or maybe we're even doing the kind of client talks to one, client talks to the other handshake, and nothing is ever really mingling. But if I tried to run those in one whiskey container as microservices, but deploy them to the same virtual env, run one whiskey container around them both, boom. Not going to play nicely. There's two different ways of vendoring. One is that you put everything into a namespace, so like the under vendor namespace. The other one is you put it in the namespace, but you do an import hook. So say you had LXML vendored, you'll end up having it at the root LXML in your Python memory. So sys.module square bracket quote LXML will be the one that came from your vendor tree. How's that going to work when you've got two different projects trying to vendor the same thing? It doesn't, is the answer. Now, requirements files. Who here doesn't know what a pip requirements file is? Right, I think I got that. So, they're actually pretty cool, right? You say, I need this exact version. This is the version I know works. Test with that, deploy with that. Everything's predictable. It's wonderful. It solves all the problems with mirrors because it doesn't matter how far the mirror moves ahead. You've still got the version you know works that you last successfully tested with in place. It's got some downsides. The first is it describes a deployment. So it describes every single thing you're going to install. Or you could describe a subset of them, but that's not generally that useful. But it installs everything that's referenced. If you have something that you sometimes install and sometimes don't, you have a choice. You either put it in your requirements file and it's always installed, or you don't put it in the requirements file, and when it is installed, it just flaps all over the place and takes whatever the latest version in the mirror is, or the latest version described by your dependencies in your setup.py. So it's almost what we want. There's a thing called Buildout. Buildout is wonderful. It's exactly the same as a requirements file. It uses easy install. And it's got the same issue with multiple projects that vendoring does. And requirements has this as well, by the way. if I have two separate microservices, I have two separate requirements files. They can have different values in them. I'm now incompatible. Or I have one requirements file that I'm using to describe a deployment of those two microservices, but now I am coupling my testing and my deployment much more closely than I want to, because sometimes I want to be able to deploy reliably, but I don't necessarily want to have my test environment exactly match all the other users of this who might want to deploy it differently. When they do deploy it, I want to know it will work. These are slightly different things. So we came up with this thing that I'm going to call the new shiny. And it's aimed at solving this problem. So a better name for it is constraints files. So the difference between a constraint and a requirement is something you need. A constraint is a rule about when you have something, what it has to look like. The syntax may be familiar to you. It's a requirements file. And you use it by saying pip install -c myconstraints.txt and any other things you want to install. And this is the important bit. You still have to specify what you're installing when you use a constraints file, because it doesn't actually trigger the installation of anything. And it doesn't describe a deployment. It describes a consistent universe of packages. So you put all of the things in there for your project. If they get installed for some reason, the version specified in the constraints file is the version that will be installed. When you've got multiple projects, you have a constraints file per thing, is one way of running it. And you can merge them together by just pulling them in and checking the lines are compatible and outputting a single unified file. You can give pip multiple constraints files on the command line. You can use the includes feature that requirements files has. You can use that with constraints files as well. Another thing you can do though is you can say, look, if we're one organization, we're producing multiple microservices, we just want one set of constraints. We want to know that everybody is running the same dependencies everywhere. And when we go and move something forward, we want to know it works with all of our services before we roll that forward. So you describe all of the dependencies across all of your projects in one big constraints file, put that in a separate Git repo, and make changes to it, go through a CI process that makes sure everything else can run their tests. So I think you should use this all the time because I like it. I think it's really actually kind of finally pulled together an answer that works and will work in all the scenarios I can think of. However, a really prescriptive checklist would be to say if you've got multiple projects or you've got optional dependencies, then as far as I know in the Python world, constraints files are really the only answer that will address those. If you don't have multiple projects and you don't have optional dependencies, any one of the other ones is actually quite a reasonable alternative. Now, all of the options I talked about before, when should you use them? Single project, these are kind of the inverses of the two things I was saying before. And there's the special cases. We should talk about the special cases. They're kind of fun. But first, you're not the special case. Unless your name is Donald or Jason. These guys are the primary authors of pip and setup tools, by the way. And pip and setup tools and virtualenv to a degree, which is also maintained by Donald, are the special cases. And they're the special cases because they are the things that know how to install things. If you don't vendor in that situation, then it's not possible to bring in the things that are needed to install the thing that installs things. So you have to bundle everything together. Other than that, no one should ever vendor anything ever, and I am looking at requests. Caveats. So I think there are things we can do that will make life better than constraints files can make it, and these caveats kind of talk to where those limitations are today. So the first thing is pip compile. Pip compile is really cool. It essentially does everything pip does, but doesn't install stuff, and it does recursive resolving to try and figure out actual versions that are needed. So one of the hidden secrets of pip is that if you have a requirements file that says I need to install LXML and LXML proc, and you've got something you're installing that depends on a different version of LXML proc, for example, the version you specified in your requirements file is the version that will get installed. And the same applies to constraints files. But this isn't because there's something special about requirements file processing or constraints files processing. It's that pip is incapable of reasoning about multiple versions of a single package. So it's this really simple, right down to the plumbing, it can't do it. The first time it gets told, hey, this package is something I might need, and here are the versions I care about, at that point it figures out a version that satisfies those rules, and that's the version it runs with for the rest of that command. And this leads to really poor behavior when you have two projects depending on the same thing. Because if one of them changes their requirements in a way that's not compatible with the other one that also depends on that common element, then the version of that common element that's chosen is going to break. Pip compile avoids that for kind of the common cases. It goes away and chews on a requirements file and comes back with a set of versions nicely annotated that will work for you, except when it doesn't. And the reason it doesn't sometimes is that this is actually a non-polynomial complete problem. So it is as hard as anything we know how to solve at all. There's some work going on upstream in pip to try and get a kind of optimized version of this built into pip install, but today, use pip compile. Oh, I didn't mention, constraints files came in pip 7.1, so you need to have a pip release this year to use it. And you should put pip compile, or whatever you're using to assemble your requirements and constraints files, in cron. You want to know when that security release of a package comes out. The flip side of having everything really reliable because it's completely repeatable is that you're in stasis and nothing's changing. So you've got to have some pressure on you, some process, and automate it so that it's not a manual process for finding out, hey, there's something new and it works. Then you should pull it in and you should start running with that. You might say, hey, we should run with the oldest version we can because we're using the distro packages. And as I said, they're ancient. And unless you're in kind of the top 10% of the package universe where you're going to get security updates, it's actually more dangerous to do that than to be running off of PyPy where the vendor or authors are actually putting their releases up. The 10% is a wild-ass guess. I don't know what the actual figure is, but there's a very steep Powerlaw curve when you look at how many packages are on PyPy that are maintained versus the ones that are in the distros. Mixed Python versions. So what I mean here is that if I've got a piece of Python software and I'm releasing it for 2.7 and 3.4 and 3.5 and 3.6, the dependencies, as people slowly drop support for older releases of Python, may start breaking. And so you have a choice. You can either say, well, I'm not going to release for those older versions anymore either. Or you can say, well, I need a different version on Python 3.3 than on 3.4. Because there's a version of the dependency I've got that works on 3.3 and not on 3.4, but I want the latest version when I'm deploying in my modern 3.4 environment, so I want that latest version there. PEP 426 markers, which there's now good ecosystem support for, will let you express that in a requirements file. I didn't think to put an example in here, I'm sorry. But the way you'd write it in a requirements file is you put a semicolon, Python underscore version equals quote 2.7 quote. And that would say, hey, this line only applies to Python 2.7. So we wrote this tool in OpenStack called Generate Constraints, which installs a requirements file into a virtual env with a particular version of Python. And then it does it again with another version of Python, and it compares the results and their versions. And if they're the same, it writes out a normal requirements file. But where they differ, it uses markers to say this applied to this one or this applied to that one. And so you run it, it comes back. You've got a requirements file that you can use to describe all of the different environments. And because the requirements files are constraints files, are requirements files, you can use that to go away and do your deployments, your test deployments with constraints. Loosen your dependencies. So I breeze past having really tight dependencies in your setup.py and how that works badly when you release something and it interacts with other things that have constraints. Now I've mentioned how primitive the pip resolver is today. You can see why that's going to be a problem. So make sure your dependencies are loose. Rule of thumb, you should record the things you know. I know that this version is bad for me. Either it's buggy or it doesn't have below this version doesn't have features I need. And this particular version broke me temporarily and I'm going to fix it in the future, but right now that version's bad. Don't guess that a new version will be bad. That's where you get into the problem where you start putting less than, tight ranges, you do a release and you regret that for the next 6 months. Yes. And the other final constraint, caveat, is that if a dependency is not listed in the constraints file, it's unconstrained. The first reference to it from somewhere is going to go and grab the latest version or the whatever version matches that reference off of your mirror. So you can potentially install any version of something in that situation. So I think the best thing to do is to make sure that all of your dependencies are in the constraints file and compile out using something like generate constraints the transitive dependencies from those, and then you've got everything locked down. So that's the other thing I didn't really touch on before, is that if you depend on X and X depends on Y, Y's changing can still break you. So you really need to pin down everything. You don't need to depend directly on Y in your project, but you want your constraints file to list Y. Okay, so pip's got some really interesting code in it. It's what's known as Apostle's tarpit. There's a huge set of things that package installations from Python have to do. There's a lot of years of people writing setup.pys that do utterly crazy things. And we have to be able to install any of them. Or people complain, they say pip's broken. They don't say this thing that was written 15 years ago and isn't Python 3.4 compatible and never will be is broken. They say pip's broken. So we've got all these corner cases, we've got a bunch of legacy code, and I'm going to be talking about this in some more horrific detail on Sunday, first thing. So please come and see that. The impact that this has on constraints is that we actually implemented constraints by injecting a requirement inside pip's internals and then adding a flag that says we're not going to install this. This isn't quite what you want. What you want to say is here is a rule to a check when someone asks for a thing to be installed, and it would be cleaner. But, it works. I just said that, so I'm not going to go over that slide again. So in OpenStack, we had this fun problem. We've got nearly 300 dependencies across all of OpenStack. And if you think that each dependency probably does a release a year, and there's only so many working days in a year, how many mistakes does it make, either on OpenStack's part in the way we've used something or an upstream when they did a release, before we have a break in our CI system every single workday? Not actually a very high failure rate is needed to achieve that. One mistake a year per project, and we are in a hellish environment. So that's what prompted building out this constraints thing in the first place, because there's this project called devstack, and devstack runs pip dozens of times. It runs it for every single separate library in the OpenStack ecosystem that OpenStack itself develops, and it runs it for each of the OpenStack servers, and it might run it a few more times just in case. And we were breaking left, right, and center. We were breaking when we released things that we'd tested with ourselves that we were sure worked, and found out that we hadn't actually tested corner cases. So if you are using devstack, it's dead easy. You export use constraints equals true, and under the hood that checks out the right repository, passes the -c flag and the path to the requirements file. And the requirements file has been vetted by going through CI itself. So we've made the changes to it by putting up a new version, compiled out to generate constraints, and run devstack tests against it. So we know that it worked. Now, we don't have all of the different combinations of devstack running backwards against it yet, but that's something we're kind of trying to find a good balance on, because some of the devstack tests are flaky, so we don't want to reject things that actually would work. On the other hand, if we don't test something and it breaks, it's kind of not surprising. For TOCs, in unit tests, we don't have any protection yet. There's some draft patches up to use it, and this is actually really, really clever. Can you guys read that? Is that terrible? Okay, so you need TOCs 1.8 to do this, but Sachi, who's been doing this bit of the work, has found that you can specify a custom pip install command per environment and creates sort of an environment on the fly by doing this constraints colon bit here, and then pip install, and there's a bunch of stuff there. It's exactly the same as the normal install command that this project's going to use, and then -c, and you pick up an environment variable which will let people put the requirements file they're using anywhere they want to, and it's got a default value there for the case where someone is running it in CI and we've got all the bits assembled just so. And you use that by going, tocs-e py27-constraints, and the dash constraints is inferred by tocs to mean use this different command. It's very, very pithy. You don't need to go through and change all of the different test environments and so on, and I really like it. You need to check out the constraints file separately. In the CI system in OpenStack, obviously we've got the glue to do that, but local developers that want to use this will need to do it. And the reason the local developer would want to do this is this means they're running the same stuff CI is going to run, so they won't get surprises. Questions? Or is everyone just going, oh my god, it was a talk about dependencies, I want to kill myself? Well, that is the cultural thing at the moment, isn't it?
Do you have any idea how far away pip getting proper dependency resolution is?
I have a working branch.
Has there been discussion
upstream? Yeah, so I have a branch that pip has a lot of legacy code. There's a lot of assumptions in there, like we're only going to deal with one version of a dependency during our run at all. So there's a whole bunch of code in my branch that changes that assumption and gets rid of it, and instead it can build a cache of, LXML 1.0, LXML 1.1, LXML 1.2, and all of that, and checks them out on disk and uses all your disk space until the world explodes. Then there's the second half of it, which is about 15 lines, which is the recursive resolver. So to get the patch in, that big chunk actually is where most of the review is going to need to take place. I need to update my branch and get it back up for Donald and get him reviewing it, but he is very interested in having this. There's also a UI thing, which is at the moment, because of the fact that there is no resolver, we just take the first thing we're given. When you want to override something, when you, as a developer or deployer, know better, it's very easy. You just put it as the first line in your requirements.txt file, it's order sensitive, you've won. When we have a resolver, which will detect that something down in the bowels of your dependency tree actually claims to be incompatible with this thing you've chosen, pip will no longer be overridable in that fashion. So we have to come up with some UI way, like maybe 4 equal signs in a row, to say, I actually mean this. So 3 is, so 2 means the same. 3 means the same even if the version number is not a legitimate version number. So we can't use 3 equals. So 4 equals might mean, I choose you. So look, potentially, if I didn't have anything else to do next week, if you wanted to take it over next week, it's all there. It's so close. It's frustrating.
What equals bang?
Is that exclamation point or BANG?
Either.
Look, I don't know, but I mean, this is basically send an email to dist-util-sig and say, I know this is coming up and this is my land claim over what it's going to be. I'm thinking like less than 3. 2 towers? We can use UTF-8, right? Snowman.
Yeah, time for one more quick question. Nope. All right. Thank you very much, Robert.